Look at this from a distance, and it barely looks like a ship. Long steel legs rise vertically from a flat hull. A bridge stretches away from the bow. Farther offshore, another platform waits. Then another. Connect all three. Lower their legs to the seabed. And suddenly, the water itself has a roadway across it. That is the idea behind China's so-called Shuiqiao, or water bridge, system. 3 specialized, self-propelled barges that can link together into a temporary pier, roughly 820 meters long. And the strange part is that these vessels do not solve the problem by behaving more like ships. They solve it by temporarily becoming something else. So how do you build a vessel that can float to a coastline, plant itself on the seabed, lift its hull above the waves, unfold a bridge more than 100 meters long, and connect with 2 other ships to create one continuous route to shore? To understand that, we have to start before the bridges ever touch. The name Shuiqiao is not an official class name released by the Chinese Navy. It is an analyst label, meaning water bridge. Open source researchers have provisionally divided the 3 vessels by length into the Shuiqiao-110, Shuiqiao-135, and Shuiqiao-185. The exact numbers should be treated as estimates, but the differences between the 3 ships are unmistakable. The smallest carries 4 tall support legs. The middle platform carries 6. The largest carries 8. That is our first clue. These are not 3 copies of one design. They appear to be a coordinated set, built for different positions along the same temporary pier. In January 2025, satellite imagery of the COMEC shipyard on Longshui Island showed the system at a rare moment for an otherwise secretive military project. One 3-vessel set was close to completion. Another set was still being built. That imagery gives us the earliest stage we can defend with confidence: the hulls themselves. They are broad, box-like structures with enormous open deck areas. That shape is not glamorous, but it gives the designers what this system needs most: space, stability, and room for equipment that would overwhelm an ordinary landing craft. We do not have public drawings showing the exact steel grades, weld procedures, or internal framing sequence. So those details have to remain unknown. But what the construction imagery does show is the scale of the problem. Before this can become a bridge, it first has to become a ship strong enough to carry the bridge, the lifting legs, the machinery that moves them, and the loads created when all of that equipment begins pushing against the seabed. And that brings us to the feature that changes everything: the legs. Jackup technology is not new. Offshore platforms have used versions of the idea for decades. A floating structure moves into position, long legs descend toward the seabed, and a lifting system raises the working platform above the moving water. But Shuiqiao applies that principle to a mobile roadway. The 4, 6, and 8-leg arrangements are one of the clearest visual differences between the 3 vessels. The smallest ship, intended for the shallowest part of the route, uses shorter legs. Farther offshore, the larger barges use more and longer supports, where the water is deeper. The exact internal lifting mechanism on Shuiqiao has not been publicly confirmed. That matters, because it would be easy to look at a patent, see a plausible mechanism, and assume the production vessels use the same thing. They may not. What we can say is that Chinese engineers were working on closely related ideas before Shuiqiao appeared. A patent filed by China Hazon describes a special work vessel carrying deployable bridges and a hull lifting system. The concept is strikingly familiar. Move the vessel into position, lower supports, raise the hull, deploy long bridge sections, and create a temporary crossing without relying on fixed harbor infrastructure. That patent is not a blueprint for these exact ships, but it shows that the engineering problem had already been broken into the same basic pieces: float, stabilize, lift, bridge. And building the real vessel means making all four happen on one hull, without one system interfering with the others. Now look at the deck. The long bridge structures sit along the centerline like oversized pieces of industrial machinery. When stowed, they have to fit inside the vessel's envelope well enough for the ship to move. When deployed, they have to reach across a gap that would normally require a permanent pier or a separate floating causeway. Public analysis puts the deployed spans at well over 100 meters, with detailed estimates around 125 to 130 meters for some of the connections. That creates a difficult structural problem. A bridge this long is not only carrying its own weight, it must maintain useful alignment between platforms that arrived independently, settled onto different points on the seabed, and may be working at different water depths. So the bridges only make sense because of the legs, and the legs only make sense because of the sequence. Before the roadway extends, the vessels first have to stop behaving like freely moving hulls. During the 2025 beach trials near Zhanjiang, the three platforms demonstrated that transformation in public view. They moved into position. Their support legs descended. Ballast helped increase the load, pressing the supports into the seabed. Then the hulls rose, reducing the direct effect of waves on the working platform. Only after that stabilization does the spectacular part become practical. The roadway sections extending between one elevated platform and the next. If you are enjoying this kind of engineering-first breakdown, subscribe to Modus Assembly. It helps us keep turning unusual industrial systems into documentaries about how they are actually built and made to work. Because the next problem is even more interesting. Why does the system need 3 different ships? Start at the shoreward end. The smallest platform has the shallowest draft and 4 shorter legs. That gives it a better chance of working where the water becomes too shallow for the larger vessels. Its job is effectively to bring the route as close to land as the system can reach. Behind it comes the middle platform with 6 legs and additional roll-on, roll-off interface structures. Then comes the largest, the roughly 185-meter platform, with 8 legs and more docking positions. The progression is almost architectural. Shallow water, intermediate water, deeper water. Instead of asking one giant ship to operate across all 3 zones, the system divides the shoreline problem into separate structures and links them. That also explains why the largest vessel does not simply drive all the way to the beach. Its size and draft work against it in shallow water. The smaller unit becomes the final link. Once all 3 are elevated and connected, the individual barges begin to behave more like sections of infrastructure than vessels. And now the number from the beginning makes sense. About 820 meters. That is not the length of one bridge. It is the combined reach of 3 hulls, their connecting spans, and the shoreward extension, working as one temporary route. The deep water end of the system also has another job. The larger 2 platforms provide multiple interfaces where roll-on, roll-off ships can come alongside. Instead of forcing every transport vessel to approach an unimproved beach, cargo can transfer onto the temporary pier and move along the connected roadway. This is why the Shuiqiao story is really a logistics story disguised as a shipbuilding story. The hulls matter, the bridges matter, the legs matter, but the final product is the path created when all of them work together. And that final product cannot really be tested in a factory. It has to be tested in water. By early March 2025, the first known trio had left the shipyard and appeared near Zhanjiang. Images from the trials showed the system in the configuration it was designed to reach. Platforms standing on their legs, long bridges deployed, and the three vessels connected into a continuous structure. Testing also included interaction with roll-on, roll-off ferries. That step is important because a bridge can look impressive and still fail at the interfaces. A useful temporary pier has to solve transitions. Ship to platform, platform to bridge, bridge to platform, and finally, platform to shore. Each transition introduces alignment, load, motion, and clearance problems. And the sea does not care that the engineering drawing is neat. Waves, currents, wind, changing water depth, uneven seabed conditions. All of them push the structure away from the clean geometry engineers want. The Jackup configuration is the system's answer to part of that problem. Once the hull is elevated on bottom-supported legs, the working deck can become much more stable than a conventional floating causeway, moving directly with the surface. But that does not make Shuiqiao a magic harbor. Public evidence still leaves major questions unanswered. We do not know the exact environmental limits of the production vessels. We do not have an official load certification for the bridge spans. We do not know the precise machinery ratings, crew requirements, propulsion power, or how quickly the full system can be assembled under every real-world condition. And those unknowns matter, because the most dramatic image of Shuiqiao is also the easiest one to misunderstand. 3 connected barges do not mean China has invented a replacement for a permanent port. A permanent port has storage, cranes, roads, traffic management, maintenance capacity, utilities, protection, and enormous throughput built into a fixed location. Shuiqiao appears designed to solve a narrower problem, creating a relocatable connection between ships and an otherwise difficult shoreline. That can be strategically significant, without being unlimited, and the program did not disappear after the first photographs. By 2026, United States military analysis reported that at least 2 sets had been observed in operation, with another trio associated with testing activity in January. That continued activity matters because it suggests Shuiqiao is not just a one-off engineering demonstrator. It is a system being repeated, and repetition changes the manufacturing question. The first challenge is proving that an unusual mechanism works. The second is learning how to build it again. A repeated design forces a shipyard to standardize large structures, installation sequences, bridge components, support systems, interfaces, and testing procedures. Even when the details remain hidden, a second set tells us something important about the industrial direction of the program. The concept has moved beyond a single strange prototype, which brings us back to the image we started with. A flat ship, a forest of vertical legs, a bridge stretching across open water. None of those features is revolutionary by itself. Shipyards already know how to build large steel hulls. Offshore engineers know how to support platforms on the seabed. Military and civil engineers know how to build modular bridges. Roll-on, roll-off ships already move vehicles through ports around the world. The unusual part is the integration. Shuiqiao takes technologies that normally belong to different industries and forces them to cooperate in one sequence. A ship arrives as a ship. Its legs descend. Its hull becomes a platform. Its bridge extends. Another platform does the same thing, then another. And when the final connection closes, the object in front of you is no longer easy to describe as 3 vessels. It is temporary infrastructure that arrived under its own power. That is the central engineering answer. China did not build one enormous amphibious ship. capable of reaching every shoreline. It divided the problem into 3 differently configured mobile platforms. Moans gave them the ability to stabilize themselves against the seabed and connected them with long, deployable roadway spans. The result is a pier that does not have to be waiting at the destination. It can arrive. And for Modus Assembly, Yao, ensign for Isiu for Shuiqiao worth watching. Not because every claim made about it is proven. Many are not. But because the part we can actually see is already unusual enough. Ships, built to stop being ships, stand on the seabed and turn open water into a road.